and welcome to Ausri. As Simon mentioned, my name is Gordon, and for those that you don't know me, I've been with Esri Australia now since 2007. When I joined Esri Australia, I specialised in imagery and LiDAR. Over time, this evolved into 3D and 3D data management. And as a side interest, I look after the Cadastre and Property Administration suite of software as well. In 2016, Esri ventured into the drone market with Drone to Map. Some of you may remember an afternoon with Jack at the Opera House, where we launched Drone to Map in Australia. Well, since then, the drone market has evolved, and in January this year, Esri purchased a product called SiteScan, which is a cloud management and drone processing engine. Today, we're going to introduce you to the capabilities of SiteScan.
So let's take a look at what we'll cover off in this session. First of all, we'll start by looking at why drone collection data is unique. We'll look at the GIS-ready products that come from drones, the complete end-to-end collection cycle with SiteScan for ArcGIS. We'll look at some of the key undertakings with flight planning components, what some of the considerations are around post-processing, and then finally, how do I push that out to my organization? So let's take a look then at why we go and fly drones. Well, drones really fill a critical gap in the image lifecycle. They provide both a spatial and temporal resolution that's not filled by other means. Satellites are great. We know satellites are great. They've been around for a long time, and they provide a good temporal resolution, i.e. a repeat cycle of anywhere from 3 to 30 days. But being satellite, the resolution is not really there for a lot of what our industries are after. So anywhere from half centimetre up to 30 metres, depending on what the requirements are. They do have good spectral resolution though, meaning they have infrared, they have thermal in some instances, and far infrared. Aerial photography is also good because we can get good resolution, 5 centimetre resolution imagery, and we can get that on regular flyovers, so half yearly, yearly sort of flyovers. The issue with aerial photography, though, is that it is expensive to run, and so generally we fly very large areas. So drones, though, they fit in that niche area where we want high temporal resolution, so I can fly every day, every week if I require, and they give me a really good spatial resolution as well. So when I say a really good spatial resolution, I'm talking anywhere from half centimetre, centimetre and a half, which is really good for doing some of that intense AEC type work where we want to understand volumetrics, we want to do profilings, those sorts of things. And it's very good complementary technology for the aerial photography for your wider area imaging capabilities. So some of the products that come out, well, most of us, when we think of photography, we think of basically the ortho mosaic, which is a seamless stitched together series of photos. But because every single point is imaged on the ground anywhere from 16 to 32 times, depending on how we configure the aerial photography flyover, we can get good elevation models, good terrain models, good contouring. So we get these beautiful 2D image sets come out. But not only that, we get very good 3D data sets as well. So we get high resolution LAS files or point clouds, and we get really good 3D modeling. And this is the 3D reality mesh that we're starting to see come into the market these days, like 3D photography. And of course, there are other philosophies around inspections. So the ability to pop up a drone, go and inspect certain places. We can do individual photos. We can do videos as well. But also we can pop the drone up and we can do the 360-degree panorama videos or images, which are very powerful for when you actually want to understand the situational awareness. So let's look at the collection cycle now and the typical pattern. Well, the way we understand this is, first of all, if we think about tasking or flight planning, deciding where you're going to go and fly, how high and how far you're going to fly, what the camera angle is, and all those sorts of things. And if you're going to set up a flight pattern that you're going to want to repeat over and over again. So once that's thought about, that's decided on, the drone is decided on as well, you then go out and do the collection. And this is the actual performing of the flight itself. And this is pretty much a set and go operation. The drone goes up, takes the video or the images that you're after, comes back and lands. Key then is once it lands, that's where all the magic starts to happen when we do the post-processing. We take the individual images and we process them into GIS-ready products. So those orthomosaics, those elevation models, those terrain models, they all come together in one system. Once we've got that, then we start to understand how that video comes together or how that imaging is affecting our site. So things like being able to do volumetric analysis, profile analysis, do time enabling across a period of time, multiple flights, those sorts of things. That's the exploitation part. And then finally, you want to be able to then distribute this to your organization. You don't want to keep this data locked up. You want to make it available to everyone. So if we can push it out to products like ArcGIS Online or BIM 360, and then maybe into machine learning applications as well. So there's quite a power in the whole process. So SiteScan provides the full end-to-end workflow on getting this kind of thing connected. We do all the tasking and the flight planning in the application itself. So we have an application that runs on the iPad. You can do it in the cloud, and then that flight planning information comes down to the controller for the drone on the iPad. You then set the flight, and you go and fly it with SiteScan. So you navigate various drones with it. The drone comes back, lands, and then you can automatically transfer the images from the drone to the controller and then from the controller to the cloud. Once the data hits the cloud in SiteScan Manager, then we can automatically process that data. And because I might have multiple operators out there with multiple drones, each time the data hits the cloud, I fire up a new machine and it starts processing. Each image set is roughly 1 hour for 150 images. Once I have it into the GIS ready products with SiteScan, I can then start to do things like download it and do some strong analysis in ArcGIS Pro. But SiteScan Manager in the cloud actually has some processing tools in there that allows me to do things like the volumetric calculations, look at it in 2D and 3D, and do profiling and things. From there, I can push it to ArcGIS Online, ArcGIS Enterprise, BIM 360 for that full end-to-end workflow. So it's quite powerful. Let's have a look at the SiteScan flight planning application in a bit more detail. It is an iPad application at the moment, soon to be coming to the iPhone as well. But it allows us to do advanced 2D and 3D flight plans. It gives us a connection directly to ArcGIS Online and ArcGIS Enterprise, and that then allows me to bring in other information such as site boundaries, obstacles, those sorts of things that allow me to improve my flying. But also I can do a quick map as well. So traditionally we use base maps from ArcGIS Online, or we would use ArcGIS Enterprise, or we might even use Google Maps as our base map. And we know those base maps can get out of date very quickly. So with the quick map facility, I can pop the drone up 110 meters, quickly fly over the area, and it will process it into basically a ready product that will give me a situational awareness. Now, that is basically the lightweight and the SiteScan flight planning application. We also have a fully connected application, which allows me to bring down those pre-planned flights and repeatable flights. It will allow me to download images that I've done in the past. And then it will also, before the drone takes off, there can be a whole series of checks that I have with my SiteScan Manager that basically says, have you checked the batteries? Is the drone fit to fly? Have you done all the clearances? All those sorts of things. They can be a predefined corporate set of guidelines. If I've preloaded ground control, it will basically load them to the iPad, and then when the data gets back up to there, it will start processing with that ground control as well. And then it will allow you to also see what other people have flown recently. So it's quite powerful what it allows you to do. The next question I get asked a lot is, what are the drones that we can go and fly with? Well, this is the suite of drones here. And obviously, the Phantom 4 is included. A lot of organizations use those. They're very good commercial drones that our organizations tend to use. I'm also seeing a lot of the Mavic Pros starting to appear now. Recently, we've been doing a lot of work with the Matrice 200 series with the interchangeable lenses. And these are quite powerful because they allow us to do infrared and thermal images as well, which SiteScan Manager fully supports. When planning, there are three principal flight modes that you would look at. Mapping for ArcGIS ready products. There's the traditional area scan, For aerial photography, digital elevation models and digital surface models, point cloud and contours, and you do it with a vertical gimbal with an 80% forward overlap and a 70% side lap. Most of your GIS ready products will come in this flight pattern. There's the crosshatch for 3D structure scanning, AEC workflows, and 3D modeling. You generally run with a 10% to 30% gimbal on these. Then one we're starting to see a lot now is the corridor scan. This is for pipeline scanning, road scanning, and areas where you need a linear coverage of something unique in a linear perspective. Now, if we're going to look at 3D modeling, we have the object scan. And this is where we actually fly around an object at multiple altitudes. It has variable gimbal angles as well to give the best three-dimensional product recreation. We then have a vertical scan where you might want to fly up the side of something like a dam wall, a mine face, or even a building, for example. It's a vertical flight pattern, and you often get photos on top of each other up the side of the wall, again with multiple gimbal angles. And then we have the two inspection type scenarios where we have a completely manual flight inspection workflow, and we have the 360-degree panorama photo. This is where we basically pop the drone up. It has a very small flight pattern and takes lots of photos and then stitches them together as a complete 360 component. Once you've done your flying, then the drone lands, and then the images are automatically transferred from the drone to the iPad. Or we can pull the SD card out of the drone, and using the iPad SD card reader, we can plug them directly into the iPad and transfer them to the SiteScan flight planning application for then cataloging and transferal to the cloud. Importantly, what happens is when we load those photos, it registers them, and then it also locates all the ground control and commences the processing as soon as it reaches the cloud. Now, SiteScan Cloud or SiteScan Manager in the cloud offers a full end-to-end processing capability. Once the imagery gets uploaded, ground control is automatically identified and the processing commences. It provides unlimited parallel processing, and a new job fires each time a new project is loaded up. As I said before, each 150 images roughly equates to 1 hour of processing. And because it's parallel processing as well, I can load multiple jobs and multiple people all at the same time, and it will fire up a new machine each time. Once completed, the imagery can be analysed in SiteScan in both a 2D and 3D. We can get elevation models, contours, we can do volumetric analysis, cut and fill, measurements, and pavement analysis. And then we can push out to the enterprise, or we can download for further offline processing. And this is one of the real key things now, is once it's complete, we can either have people with an unlimited number of viewers log into SiteScan to view the information, ArcGIS Online can consume those services, ArcGIS Enterprise can consume those, Autodesk BIM 360, or I can download them into something like ArcGIS for further analysis and detailed analysis as well. Let's take a look then at a recent flight I did with the State Emergency Service of South Australia. This is a flood mitigation wall just north of Gawler in South Australia. SES wanted to understand the volume behind the wall and the downstream channeling, as well as looking at the structure itself. You must admit it's a pretty damn impressive structure too. So first up, the SiteScan flight planning app, we see all my projects. Selecting the dam project, I'm then presented with a screen that shows all the various flight modes: traditional area survey, crosshatch 3D structures, and corridor scan. I've selected my own one, and now I'm preloading a flight plan that I had before. Looking at the gimbal, the altitude, and the hatch angle, I can make changes according to what I need. Selecting the mode, in advanced, I can set the overlap, the side lap, and the return altitude from this. It's also telling the drone which point to start from. I can continue without a link, and what that means is that the drone can continue without passing. Clicking OK and fly, it goes through a series of checks and then off the drone goes. The flight path's loaded, it takes off, and it commences on its automated flight that we've planned. You'll see the position of the drone on the flight path, and you see what the drone sees. It goes to the furthest waypoint first and starts the flight plan. As each photo is taken, you'll see a flash in the right-hand corner. Across the top, you'll see the drone readouts, satellites connected, battery life, distance away, and as it goes through, each waypoint is marked off as well. Now here you can see the Mavic Pro flying along its flight path. It's a uniform flight path, follows along, and it is taking the photos as it goes. Now importantly in this case, it reaches a waypoint and the drone will automatically turn around, return onto the next flight path, and then continue on its way. Now, with the advantage with the Flight Scan flight planning app is we can see this in both 2D and 3D. And in the future, we're going to see terrain following, and we'll be able to see it fly up the side of terrain as well. It will continue on its flight path until the mission completes. When it lands, all the imagery is automatically loaded from the drone, and I can inspect any of that imagery as required. To upload the imagery, I simply select the button across the bottom, and it starts to upload the images from the iPad to SiteScan Manager in the cloud. Once it completes, you'll see it will move from the pending surveys to the SiteScan, the ones in the cloud. Now here we are in SiteScan Manager itself. I'm going to go and select my SES dam analysis project. And here's the flight that I just did. It zooms to where all the photos are, and you can see all the photo centers starting to appear on the screen. I can go and look at any of those. I could view them in full screen if I wanted to, or download them at any point in time as well. Turning on the ground control allows me to see which ground control fall within the flight plan area. Reviewing the ground control allows me to see which photos have the ground control enabled in them, and we'll see exactly which ones are auto-identified. By looking at this photo here, for example, we can see that the black and white tile is there, and you can see the location of that ground control that's associated with it. I can also review my manual ground control, and in this case, it's a pillar of a known location, and you can see we've assigned those locations as well. With that assigned, I can then commence the processing. I can select Ortho Mosaic, the point cloud, and the mesh. Other products are also generated on the fly for us, like the DEM, DTM, etc. And as you'll see now, it tells us exactly how long this is going to take. And it processes it in the background. I can go off and commence with other things. Here's a finished product. We have a look at the ortho photo in this instance, and you can see it's clearly stitched all our photos together. And we can then go and look at the elevation data that's associated with this as well. We can go and turn on the contours, the elevation model, zoom in, see the resolution of that. We can go and look at cut and fill and understand exactly how, if I was to cut and fill some of that data, how it would look. And I can then go and look at some of the 3D products as well. So going and looking here, we're looking at now the point cloud that's associated with this. It's a high detail point cloud at maximum resolution. We've got it decimated at this point so we can ease the performance. And you can also see on the left here, I've got some measurements that I've done in the past. I can then get at my full 3D reality model for this particular one by seeing all sides of the dam to work with. Moving back to the ortho photo, we can then start to do some analysis. In this case, I'm going to go and get the volumetric tool and understand what the exact volume is underneath the dam wall that's covered by this. Viewing, you'll see over on the left there, you've got all the information about the cut and fill. And now we'll go and look at this in 3D. It shows you on the right the area that of my interest. On the left is a 3D model of this. and you can see the volumetric plane as well. And if I had a design surface, such as a DXF, I could load that in and compare the actual calculated volume versus a design surface, and then look at that and view it all from all angles and understand the difference between them by doing a volumetric report as well. Once I have my photo in place here, I can then say maybe go back and inspect some of the points. Here we're looking at the overflow point, and you can see exactly where the overflow point appears in every one of my photos. And I'm able to scroll through those and understand and view each of those. I can then extract the products down to TIFFs, surface models, LAS files, zips, i3s mesh, as well as shape files. Alternatively, I can push that to ArcGIS Online, ArcGIS Enterprise, in all those formats as well. So this SiteScan product gives me a full understanding of what I can do and that full end-to-end piece. So let's have a look now at how SiteScan is actually licensed. There are three types of licenses with SiteScan. There is the operator, so that's the person who's allowed to fly the drones, prepare flight plans, and process flights as well. It's probably our most powerful operator or most powerful user. Then there's the access license. Access allows you to analyze, edit, share, download, and manipulate the drone project data. You require an access license to be an administrator as well. The administrator manages things like the user, the organization, and fleet management functionality, so those checklists we spoke about before. And then there is the view-only license. Now, the view-only licenses are virtually unlimited. You can supply the login to as many people as you like. You can do virtually any of the analysis that the access license can do, so some of the profiling, the volumetric calculations, but you can't make any changes and you can't download any data with it. Here's a matrix of all those permissions, and you can see principally the operator license is the only one who's allowed to do the flights and upload data. The administrator and different levels are in there as well. So covering off on this, SiteScan for ArcGIS allows fleet management, pilot tracking, and drone and battery tracking. It allows us to pre-plan flights, set the drone and camera options as well for all our flight management. SiteScan Manager automatically scales for a number of jobs that are being performed, uses machine learning to detect ground control, and perform auto processing when the data gets there. You can create as many GIS-ready products as required, and you can have as many projects in there as you need. It is unlimited storage and unlimited processing capability. Once you're complete, you can then export to your organizational platforms or download if required. Looking ahead, on the SiteScan roadmap, we see that Esri is working on some terrain following capability in 3D. We're looking at generating full motion video log files that will allow us to load the videos into full motion video in ArcGIS Pro. We'll be looking for support of new drones, including the Phantom 4 RTK, the Matrice 300, and some sort of vertical lift-off drone in the short period. And we're going to be able to daisy chain inspection flights. In the SiteScan Manager in the cloud, we're looking at enhancing the flight management piece, improving the inspection workflows, publishing an orientated imagery catalog to support the Esri orientated imagery application, and tighter integration with ArcGIS and ArcGIS Online. If you want more information, there are the Esri sites for SiteScan for ArcGIS, which is a product overview. There's a training course getting started with SiteScan for ArcGIS that is available. There is a FAQ on all the bits and pieces associated with this, and then there's a full knowledge base as well, which I highly recommend you go and inspect because it will give you some key tips in doing things like uploading imagery and processing as well. I hope you found this session informative, and I hope you go and have a look at SiteScan now. Thank you for attending. Goodbye.